In this video, we're going to be looking at the concept that is known as the scientific method, that is really popular ideology that is really practiced at the scientific community. And this here involves the following: how do we be able to perform inquiry strategies in order for we to extract knowledge and understanding of various phenomena that are happening all around us, either naturally or through experiments. There are a couple of steps that are required that we're going to dive into in details, and these steps includes the following. First is to perform observations about everything that is around you, and this here will be followed by making an hypothesis. I'm going to look at what this is all about, and next step is performing experiments, and these experiments can be either done one by the individual or by a series of peers. We'll talk about this when that happens. And finally, here is the theory. So we're going to be looking at how to go from an hypothesis to a theory about various observations that are made around you, how we're going to place them in a particular style, which is a flowchart, and how they all interact with each other, when we're going to be looking at examples of how this here plays a role, not only in terms of the historical part, but also the future of the scientific method. Now, looking at the scientific method, this was first introduced in the 17th century, where scientists like, for example, Galileo, everyone might remember that name, of course, from physics, but also we had Bacon, Francis, and we also had Newton. All these interesting scientists were able to use the scientific method to explain various natural laws. First performed observations, and these observations were either natural or they were through experiments, and based on these they were able to observe various patterns, and these patterns were able to allow them to make hypotheses about these particular observations, or we call them natural phenomena. Now, this here is a temporal reasoning behind these observations. This is where the big part comes into play, where the scientists, they then develop experiments, and this experiment here is at the developing stage, and there are two ways. One is focusing on the development, and by developing these experiments, they have to use this to check for their hypothesis, and if it is awesome and it agrees with what the hypothesis is all about, then this moves on to the next step, which is a model. Now, if it doesn't make it to the model stage, then this experiment, which if it doesn't agree, we have to undergo a review of the hypothesis, and a review of the hypothesis will be done for them to two ways: either debunk, put it in the trash can, or on the other side here, make some modifications on the hypothesis, and then they do the development of experiment to see whether the new hypothesis matches this particular experiment, or the experiment really proves the hypothesis about the observation. Now, moving forward here to the model stage, this model stage is done to improve the hypothesis, and this here could be one or many models that could be developed. If you have one or more models, this is where competition comes into play. Now, take note here that in this case here, when it gets here to this stage from the model, we have to improve the model's prediction. This is another type of experiment, and this here is where we have other peers trying to replicate that experiment that was developed here at the initial stage, to see whether it is a little bit more accurate, and it is subjected to different conditions. Like, for example, if there is one particular region where you're planning to do the experiment that wasn't done in the original one, this is where they try to test the boundaries of that particular experiment on the explanation for the hypothesis. And so this here, take note that for this experiment, part 1 here is when you have an accurate experiment that is designed. However, this here is when your experiment is not really accurate. However, it is not agreeing with the original development, but there's like a slight thing that needs to be changed. This will undergo a particular review of the model, and then this model would then be redesigned or retested again and further improved upon as time goes on. And then the final step is, once your model has been improved, this is where it now becomes a final step, which is called a theory. And so a theory here is improved models that is to be challenged in the future or to be modified in the future. Now, there are some cases where we're going to have multiple models, and when you have multiple models, to get it to the theory, the one that has little assumptions, or the theory that has the best one that is what more predictable in terms of events, is the theory that is going to be the big theory here, and the other ones can either be modified or debunked. But anyways, looking at the theory here, this here shows two benefits. One is to be able to predict what future outcomes, and final one here is to explain natural phenomena or concepts. So this here is how observation, the hypothesis, the experiment stage, and the theory stage comes into play, looking at it in a particular flowchart design like this. Now we're going to look at applications of this, where we have Copernicus, who is a particular scientist, and this scientist here, what he did was he was able to do what? To use or to introduce a natural phenomenon that was able to describe the orbit and how the Earth relates to a central body. And in this case, he said that Earth rotates around the Sun at a particular orbit that is circular, and this here was done using experiments and was reviewed at his time, and it was the model at that time, but then all the theory at that time. But then half a century later, a particular scientist by the name of Johannes Kepler, he came up with a new theory that improved on Copernicus theory, and this here states that yes, of course, different bodies, planetary bodies, they orbit around central bodies, but the orbit most likely is an elliptical orbit, not a circular orbit. And so this was a way to improve on Copernicus' original idea. And in this case here, the Copernicus idea was really incredible because it was able to predict future things, like for example, the current and future positions of planets in a particular system. So it's pretty impressive to see an application of such design and how the scientific method was able to introduce such a great idea, and it's currently being challenged as time goes on. Like for example, looking at two-body problems, or when if we have a three-body problem, all those big concepts are the things that are current ways by which we can challenge the scientific method based on planetary bodies in terms of the shape of their orbits. So I hope you found this really informative. Hit the comment down below, let me know your thought about the scientific method, and I hope to see you all on the next one. All the same, stay smart as always and believe in yourselves.